Hello students, today I'll be discussing with you numericals which are based on mass defect, binding energy and binding energy per nucleons. So before starting with actual numericals, we'll be discussing formulas which we are going to need. Okay, so we are discussing about the mass defect. Now, as you are aware that if there is an atom, so that atom is made up of nucleus and orbits, and in that nucleus protons and neutrons are there, and that we call them as a nucleons. If we find out mass of nucleus m, and if we separately add masses of nucleons, okay, so and if we compare that two value, so there is always difference between their masses, and that difference is called as mass defect. So we can say that sum of masses of nucleons minus mass of nucleus. So that difference is nothing but mass defect. So del m is indicating mass defect. Now, so we can write formula for mass defect as ZMP, where Z indicate number of protons. So number of proton into mass of proton plus A minus Z. A minus Z will give you what? A minus Z will give you number of neutrons which are present. So I can write instead of A minus Z, N also. So ZMP plus N into Mn minus. So this whole part will give you sum of masses of nucleons minus mass of nucleus. So it will, so that difference is mass defect. So this is our required formula for mass defect. Now let's move to next point, which is binding energy. Binding energy we can get by formula mass defect into c square. So you need to just put a formula which is there for mass defect into c square. It will give you binding energy. Then if that mass you are substituting in terms of kg, then binding energy you will get in terms of joule. But many times you will find that numericals which are given, their unit is given in terms of atomic mass unit, and you can convert that atomic mass unit into mega electron volt per c square as one atomic mass unit. One atomic mass unit is nothing but 931 mega electron volt per c square. We can get energy as formula for energy. Binding energy is del m into c square. If it is in atomic mass unit and you want to convert it in terms of mega electron volt, so you'll have to multiply it with 931 into 931 mega electron volt per c square, and the c square will get cancelled out. So remaining term will be del m into 931. Therefore, binding energy you can express in terms of atomic mass unit also, and you can convert atomic mass unit to mega electron volt also. So this way you can get your answer. Now next formula is binding energy per nucleon. Formula for binding energy per nucleon is total binding energy upon mass number, and mass number we indicate with capital A. So you can write which is equal to del M upon A into 931, and that answer will be mega electron volt per nucleons. Now let's solve numericals. While solving numericals, you are going to need this constants: mass of proton, mass of neutron, and mass of electron. This constant will be given to you directly. So these are masses in terms of kg, and here in terms of atomic mass unit. You can convert, if it is given in atomic mass unit, you can convert in terms of mega electron volt per c square by multiplying it with 931.5. So many times you will find that uh, here 7 2 instead of 7 6, we'll just round off and we can write 7 to 8. Similar way here also and below also. So this constant we are going to use again and again while solving sum. And here mass of electron you can write this way also: 0.00055. So this, in this format also you can write. So our first numerical is, this is question number 10. Calculate the binding energy of an alpha particle given its mass to be 4.00151 U. This question is there on page number 342, our state board textbook. So let's write whatever is given and then write formula. So mass of alpha particle is given, which is 4.00151 U. And as this is given in U, we are going to need mass of neutron and mass of proton as well in U, in terms of U. And as here it is mentioned alpha particle, it is nothing but twice Hu4. So its proton number is Z and N number is 2 and 2. So we are having M, value of Z, value of capital N, and this mass of proton and neutron also. So now we'll substitute and we'll try to get answer. Formula for binding energy is mass defect into c square. Mass defect is ZMP plus NMN minus total mass of given atom into c square. Now we'll substitute that values. As it is alpha particle, value of Z is 2. Then mass of proton and mass of neutron are constant value, which is already we are knowing. So that constant value will directly write. So 1.00728 is the value for mass of proton and 1.00866 is the value of mass of neutron in atomic mass unit. And this value is already given in question. So we'll write, and then simple multiplication is there: 2 into 1.00728 and 2 into 1.00866. So after simple multiplication we'll get 2.01456 plus 2.01732, and then I'm writing outside here. Then 1U, you can substitute 931.5 into c square. So let's do simple addition and subtraction for this bracketed term, and we'll try to find out answer. So instead of 1U, we'll substitute 931.5 upon c square, as that is also one of the constant, and addition and subtraction of this whole bracket is 28.2896. Then we will just cancel out the c square term, and again simple multiplication, 28.2896 into 931.5. So our answer will be 28.2896. Sorry. So 28.96 is our final answer after multiplying it with 931.5. So I'll just erase this. So we are having this answer in terms of mega electron volt. Instead of 1U, I have substituted 931.5 mega electron volt upon c square, and multiplying that bracketed term with 931.5, we are getting 28.2896, and that answer is in mega electron volt, which you can convert in terms of joule also, because mega is nothing but what? It is nothing but 10 raised to 6. And 1 electron volt is nothing but 1.6 into 10 raised to minus 19. So this way you will get answer in terms of joule, which is nothing but 4.532 into 10 raised to minus 12 joule. So this will be final answer. You can write answer in terms of mega electron volt also. That is also fine. Now let's move to next question. Determine binding energy per nucleon of the americium isotope. Given mass of americium to be 244.06428 U. Now let's write whatever is given here. Value of Z and A is also given. So, and they are asking us to find out binding energy per nucleon. So first we'll write given and required formula. So here in question only it is given 244. 244 is nothing but what? It is A, and Z is 95. So we can find out number of neutron. So number of proton is given, that is 95, and number of neutron we can find out by mass number and atomic number, which is 149. Then total mass is given, total mass of americium nucleus is given in terms of U. Mass of proton and mass of neutrons are constant value, which we will substitute, and 1U, 1 atomic mass unit, we can convert in terms of mega electron volt by this relation. And here they are asking us to find out binding energy per nucleon. But binding energy is nothing but what? It is nothing but mass defect into C square upon A. And we are aware of binding energy formula. So let's write that formula for binding energy and substitute all given values. So instead of del M, we'll write ZMP plus NMN minus capital M into C square upon capital A. Now Z, value of Z is 95. Mass of proton is constant value, which is 1.00728. N is 244 minus 95, which is 149. That will substitute. Mass of neutron, again it is constant value, which is 1.00866, minus mass of total mass of nucleus is given in question, which is 244.06428. All these masses are in U, atomic mass unit. So that is why I have written here outside U, and into C square upon capital A, and A value is 244. Now this 95 into this term and 149 into 1.0866, that you need to do separately, and then addition of that to minus 244 point that number. Okay, this way you need to find out. So let's do this multiplication and addition. So multiplication of 95 into 1.00728 is 95.6916. Similar way we will do multiplication for 149 into 1.00866, and then addition of this two is 245.9819. So 245.9819 minus 2.44. So that subtraction you need to do. You will have to multiply it with 931.5. So this you need to find out, and which will give you final answer 7.3209. So this will be final answer for binding energy per nucleon. So we can write mega electron volt per nucleon. Now another way is you can find out reciprocal of 244. That way also you can do. Or first you just add and subtract, and then whatever number you will get for this bracket. So for multiplication, A into B into C. So by using log you can find out log of A plus log of B plus log of C. So this way you can do. Where A is this bracketed term, B is reciprocal of 244, and C is 931.5. So this way you will get final answer for question number 12. Now let's move to next question. So question number 13, calculate the energy release in the nuclear reaction. Lithium plus proton is giving us twice alpha, where mass of lithium atom and helium atom is given, which is 7.016 U and 4.0026 U. Now here, whenever in question it is mentioned energy release in nuclear reaction, just keep it in mind that again you are going to use same formula only. Energy is equal to mass defect into C square, and while finding a mass defect, you are going to find out difference in the mass of parent nucleus minus product. So this is our parent nuclei and this is product. So its difference in mass we need to find out, which will gives us energy release. So first let's first write whatever is given and then we will substitute. So mass of lithium is given, which is 7.016 U. Mass of alpha particle is given, which is 4.0026 U. Mass of proton is constant value, and as I told you, del M mass defect is equal to mass of parent, total mass of parent minus mass of product nuclear. Now we'll substitute its mass, then addition, subtraction, and then we'll try to find out energy release. So let's write that given values and add and subtract. So mass of lithium 7.016 plus 1.00728 minus 2 into 4.0026. Now we'll have to multiply this with 2. Then after adding and subtracting, we'll get 0.01808 in U. And energy release, so del M into C square. So del M is now 0.01808 into. Now, if you want to convert this energy U to mega electron volt in that format, so instead of U, we'll multiply it with 931.5 mega electron volt per C square, and this square is also there. So this C square will cancel out. Again, this multiplication is there. You can do directly or by log, which will gives us 16.8415 mega electron volt. So this will be final answer for energy released. Now, next question. So here calculate the energy released in the following reaction. So three different reactions are given. Reaction 1, nuclear reaction 2, nuclear reaction 3. And here individual mass of each nuclei is given. So here as mass of atoms are given, their atomic number and everything is given. Z value is also given. But here they are asking us to find out energy release in the nuclear reaction. So again, we can find out energy release by formula del M into C square, where how to find out del M then. So del M is equal to mass of parent minus mass of product. So let's find out first for reaction A. We'll write formula and we'll substitute. So E is equal to del M C square. As I told you, first mass of parent. Now here This radium is our parent atom. Its mass is given 223.0185. So that's why I have written here mass of parent atom minus. Now mass of product. Now product is here, this Pb and C. Its mass is given, which is 208.9811 and 19.0324. So first you can add. So first we'll solve this bracketed term. Then here C square is given and all these things are in U. Well, these are in terms of U. Unit is U. So you can convert it into mega electron volt by multiplying it with 931.5. So C square will get cancelled out as we have done numericals before also. So simple addition and subtraction, and then when you will get final answer, then you are going to multiply it with 931.5. So which will give you final answer 31.820004 mega electron volt. So this is energy release in this equation A. So B also you can solve same way. Again formula is same, which is del m upon C square, which is equal to, now here in this case parent atom is U, its mass is given 236.045 and product is Ba Kr and this neutron. Now let's substitute that values. And we'll just add and we'll try to get answer. So mass of uranium is 236.045. Mass of product is 139.91. Mass of Kr is 93. Mass of neutron, it is a constant value which is 1.000866. But here it is written 2 into n. That is why you need to multiply it with 2. And when we will just do that addition and subtraction, you will be getting final result as 171.00477 mega electron volt. Okay, so this way you will get answer for B. Now here let's discuss reaction C. This is our parent, this is product. Then here mass of electron is constant value which we are already knowing, which is 0.00055. And neutrino energy, here it is mentioned that ignore, so we are not going to consider this energy. So this is our parent mass and this is product mass. This way we will find out and we will try to get answer. So formula, energy release is equal to mass defect into C square. Now mass of parent, So parent is carbon, which is 11 point, mass of, it says 11.01143. Then mass of D, which is 11.0093, plus this is product. Mass of electron is constant value again, which is 0.00055. Then we need to solve this bracket, addition and subtraction, which we'll have to do directly only. We cannot use log for it. And then you will get addition subtraction of this bracketed term. Then we'll need to multiply it with 931.5, which we can do directly or by log. As it is big, means many digits are there, you can use log. And so final answer will be 1.47177 in mega electron volt. So that's it. Thank you. In next video we'll be solving more sums.